dy dx? dy dx is equal to dy dt over dx dt. When you do that, you're going to have a function of time. So if you wanted to find the second derivative, we could look at 51. If I wanted to find the second derivative, then I would take the derivative with respect to x. And then yes, sorry, should be a t. Yeah, but this one looks weird. And I tried to do it in general like this, and I kept getting messed up. But when you take the derivative of this, you got to use the quotient rule, but then you have to do the chain rule. Because this is some function of time, isn't it? So when you do this, you're going to get all these t's here, then you're going to have to multiply it by the derivative of t with respect to x. If you want to look at 51, I can show you that. Would you like to look at 51 from 4.3? Well, I know I helped you with it though. But 51 is finding the second derivative. It's tricky.
Why tricky?
It's really tough because it's a weird.
Somebody help me out and tell me what 51 is. What's 51? What's x of t? T cubed minus 1? Oh, minus 12t. Then what's y of t? Minus 1? Oh, okay. So dy dx is equal to dy dt over dx dt. This wasn't hard. This was easy. The first derivative is easy. The second one's not. This is 2t. 3t squared minus 12. Now, to do the next derivative, it's with respect to x, not t. Now I'm going to use the quotient rule. Okay, Matt? What's the derivative of this thing? It's the denominator times the derivative of the numerator, but it's with respect to x. So it's 2 times dt dx. If you look at the answer book, you'll look at it for a while figuring out what in the world did they do to get that formula. Well, we'll get there. Minus, then it's going to be 2t times the derivative of 3t squared minus 12, which is 6t, times the derivative of the inside function, dt dx.
Is that just going to be 1 over dx?
That's correct, over the denominator squared. So 3t squared minus 12 squared. And it was easiest to simplify that. So this is 6t squared minus 24. I'm going to factor out the dt dx. You okay with that? Minus 12t squared. And having a dt dx in the numerator is the same as having a dx dt in the denominator. That's what I did fine, except I forgot the dt dx when I did it. That's what I said. This is hard. If you look at the answer book that comes with our textbook, it's even worse. I'm going, where did they get that? Well, the algebra here is actually more of a problem than you might realize. So I think we should look at the algebra. Okay, just did the quotient rule, but you had to multiply by, oops, the wrong one. You had to multiply by dt dx because you have to take the derivative of the inside function with respect to x. So without the dt dx, you're looking at dt dt, and that's not what it's asking. Well, the derivative with respect to x. We could ask this on the exam. I think it's reasonable, especially since we've gone over it. Okay. If I simplify that, I'm going to get negative 6t squared minus 24, and this is going to be Now, what I'm going to do is factor something out of there. What's dx dt? What's dx dt? It's 3t squared minus 12. So that's why they get 3t cubed. Okay, what can you factor out of the numerator? Negative 6. Let's take out a negative. It's t squared plus 4. Because finding where, I have to find the concavity. So finding where this is negative is not easy unless you simplify it algebraically. Now, I'm going to take out the 3 here. But it's not 3, it's 3 what? It's 3 squared, isn't it? Or I could take out a 3 for each one of those and multiply them together. How many 3s are we going to have here? We're going to have 2 here and 1 more. That's going to be 3 cubed. And I'm left with, now this. If I take out a 3 here, I'm left with t squared minus what? No, take out a 3. 4. You took it out of this one twice and this one once. And this is going to be to the 3rd power. Let's simplify that one more step. If you want me to write it out separately, I will. You don't get that. So I don't even care if I reduce this. It's not really important. I want where this is negative. I want, oh wait, is it concave up? Okay, Justin, over there. Over there, because you're not even supposed to have food in
I
here.
like being thrown.
I don't care. No. I know.
Is it
What?
27?
Pardon? Oh, yeah, 27. I did what you guys do. I've been teaching too long. Okay, this is always negative, right? This is always positive. The only thing that's going to change sign is that denominator. Matt, put your iPod away.
Wait, why did you have the cube?
Oops, I forgot the cube there, too. Cubed, pardon. Okay? Now, I think I'm looking for concave up, correct?
Yeah.
And when you're concave up, when the second derivative is what? Greater than 0. The only way for that to happen is for what? T squared minus 4 has to be what? Negative. You could leave it cubed, it doesn't really matter. Because I could cube root both sides. So I'm going to put a little line chart here. Where are the split points? Where is it 0? 2 and negative 2. And then I like to be clever. This is y double prime. And I know that that's a parabola. And I know it looks like this. And so where is it negative? Between negative 2 and 2. But if you don't simplify, solving is hard. So you want to simplify. Is that okay, Parker? Okay. That gets you into the second derivative. You could try to do it in general for this, but it gets kind of ugly. I might still try to write it out. But anyway, proving that you actually have to divide by dx dt. You take the second derivative with respect to t, and then divide by dx dt. I know, I had issues with it. Okay, Matt is going to do this one for us. We're going to graph this in a viewing rectangle that displays the important features of the curve. And the assignment is whatever's on 4-4, which isn't much.
It's just one problem.
It's just one problem. Because we don't need a lot of practice, we just want to get the feel for how to graph that. Pardon?
I set it up there.
You're going to be busy, so you can't be bugging them.
I didn't book them. You threw raisins at me.
I know you did.
Actually,
I
it was talking
them
about cranberries.
Yeah, it doesn't work with you guys sitting on the same side. Okay.
Yeah, yeah, get out.
You know what else that is?
We had this problem last year, too.
Show.
Okay, ready? Who needs a calculator? Any kind of calculator. We're going to do it on the 84 because I get motion. Where I don't get motion when I do it on the Inspire unless I use one of my little TNS files.
About the cast. You want the cast?
Only if you use the parametric grapher that's a TNS file on it, and I still haven't gotten that to work very well.
It works.
Okay, so I'm going to bring my calculator up. Actually, Matt could do it. Well, you just have to touch down there, and there it is. And we'll clear that. Okay. Yes. Okay, Matt, what are you going to do? What mode do you want to be in, Matt?
Radiant, Matt.
It's too little.
Oh, you can pinch it.
Whoa, it's
Did you say radiant?
Pinch it.
Yeah, that's a
Oh.
Just like your iPod.
This year, there
Who needs a calculator? Justin, you need a calculator?
Parametric.
So get it out.
Mark Reagan.
Yeah, and you want to be in parametric. So press mode, and you want to be in parametric right over here.
Whoa. It's also late.
Press enter. It will be a little delayed. It's delayed up there as well. Okay, so press y equals and put in our function. Justin, over there.
Just give me high five.
There we go. No, we're not doing that. You're supposed to be participating. There's our function. Now I'll bring my calculator back up. So we can move this around. It's t squared, x is t squared plus t plus 1. So clear it out. Mm-hmm. It is, but you pinch it.
No, it's too little for my fingers.
It's easier to go up there and do it, actually.
No, it's not this. Do the cat.
My table, or you could just start with the Zoom 4, I mean. Because you know what, if you look at x, is this ever going to be negative? T squared plus t plus 1. It's never negative. And that's a little bit of number theory. Even if you take a negative 1/2 for the time, see, that's what I mean by get a good viewing window. So x is not going to be negative. The way to figure that out for me is to go into second table set and take a look at the y values and the x values and see what they're going to be. We're going to have to do 2 parts to this because you're going to want to see the whole behavior and you're going to want to zoom in on some of the other behaviors. Mm-hmm. Started at 0.
No, start at 0.
Mm-hmm. Well, you know that x will never be negative. But this will be once. We're just going to look at our table, because I don't know. I'm going to slide this over a little bit. Sorry, just so you can see it. Okay, so you can see what the x's do. So I know that I eventually maybe want to go up to 43 on the x's, but maybe I want to see what's happening close up, too. Look at the y's. They go down to negative 110. So the y's get up to, at 6, at t equals 6, we are at 1,537. It's big. You just have to play with it. That's the whole point of this lesson. It's not obvious. So do you want to See the big behavior? So the y's would probably go from negative 150 to 500.
Oh.
I didn't touch it.
Right.
So all you do is go down here, press on that. You might not be able to see that on that. I don't know. Pardon? The y values went from a negative 110 to positive 450, and you want the time to stop at 5 because it's going to get huge. You may even want it smaller. And maybe we even want some negative time. I think we do. Maybe we want to go minus 6 to 6. Well, go up. Arrow up. Okay, how about the negatives? If we do negative 6, okay, look at that. The y's are going to go to 322. The x's are okay. So you have to go into your window. And we want T-min to be negative 6, or negative 5. Negative 5. And then T-max to be positive 5. Because other than that, it's going to get huge. T-step, I usually do 0.1. And then X-min, it's never negative, so why don't we do negative 1? As I like to see my x's. And the X-max, how big was the x's? Or the x's?
But it's like 40.
Go to 40.
And then you scale by tens, otherwise you're going to have a lot of tick marks. And then the Y-min was negative 110, so maybe make it negative 120. And then the Y-max was 450, so make it 500. I'm trying to get this. There, okay.
Okay, my graph.
Y scale, I go by 50s. And then press graph.
Go.
Slowing down. Now you really can see it slow down.
Wow.
I don't know what it's doing there, but we'll zoom in on it.
Amazing how those calculators can show time in life.
Oh, cool. Look at that. That's a nice picture. But I would like to know more about what's happening here. By the way, what's at this point right here? Absolute min, right. Now, the only way to find it, let's go back and find it. Let's go back to our graph. Because if you go second calc, guess what?
Oh,
We could find dy dx there. Where's my cursor? I don't know if I want to. Okay, now it's going to do a loop-to-loop. I did dy dx. What's true about dy dx there? It should be 0. So should numerators dy dt should also be 0. I'm not close enough. See, I'm off to the side. I didn't get close enough, but you should get 0. Let me see your calculator.
He said I have to do my memory. It's just like every time I grasp it.
No, it's invalid dimension. It's stats. Alright, so you're better off just changing the values because it takes less time. So we want the x's to go, let's maybe have the x's just go to 10. I don't remember the numbers, or do I have it? No, I didn't take a picture of that. And the y values you're going to want to change too. Because I want to see what's going on there. Okay, I don't even want the x's to go to 10, do I?
I want it to go to like 2.
If you trace, you'll have a better idea. And the y values, I only want to go up here. This is like, what, 50s? On the y's? X max was, yeah, 3. That looks good. Scale it to 1. You don't have to scale it from there. Y min, how about negative 10 or something? I didn't practice this, so it's just No, X scale you want, it won't work.
Whoa, how bad this chief?
Hey, Matt, what are you doing?
Sorry.
Press 1.
Oh, I gotta really...
Y min, let's make it -10. And Y max is, let's make it 10, let's see what happens.
What do we do for?
And the Y scale count by
See
1.
what happens?
Leave your T values the same.
Whoa.
Do 100 for your
That didn't work. Yeah, you should do it.
I'm still thinking. Okay, so let's go into our table and look at it. Second table.
It's the second chief.
If you go to a table and look at it, you'll see.
I'll fix it.
Okay.
I got
It's
this.
faster to fix it by looking at the
It's my
table.
time to shine this chief.
Yeah.
That's right.
See why is he doing that on the iPad?
Because he doesn't want to get out of his seat and do it up here.
Because he's lazy.
But I used to. Alright.
Oh, no, not 1,000. If we did a table, it'd be faster. Okay, there it comes.
There it goes.
Oh, not bad. Now that's the zoomed in picture.
Matt, what was those, I don't know, what was the last?
Gonna make it 69.
See, this you're seeing everything here. Here now you want to see where this is stopping. So I want to look at a vertical tangent, which would be right here. And what would be true about the tangents here? They're horizontal tangents. So for the green ones, dy dt is 0. For the red ones, dx dt is 0. And you could find the x coordinates there. You could do calculus. Because what's dx dt? That would be easier, isn't it? What's dx dt? 2t plus 1. When is that 0? When 2t plus 1 is equal to 0. So t equals -1/2. Let's go back to the graph. Oh, he can't do that. Go back to the graph. Now what we're going to do is do a trace. Press trace. And type in -1/2 or -0.5. And then press enter. And there it is. You see where the vertical tangent is? It was easier to see that. Okay? So x is 0.75 and y is 21.6875. You could just evaluate that, but that did it for us. Okay, what about where dy dt is 0? Okay, that might be a little trickier because it's t to the 4th. So what you can do is just trace. You know, if you're at 0.1, so it's going to take a little bit. But if you trace and, watch your direction, and all you're going to do is estimate a little bit. It's so weird. It's so the feeling is counterintuitive because if I want it to go to the right, I press the right one, but it's actually going to the left. Because it's tracing the parametric curve. Remember, it came down like this. And let me go down here and just write it so it shows up, otherwise. It comes this way, doesn't it? Yeah, it goes this way, and then it comes back around and it goes down. So it's opposite what you would think, because you're just so used to looking at a static picture. How about finding that intersection point? Yeah, all you can do is trace. The only thing you can do is to zoom in on it, on the intersection point if you want to get it more accurate, but there is no intersect button on this. Oh, well, it's probably in your mode.